isomerism? When you see system, what is system isomerism? Tell me. System isomerism is the isomerism where we are having a double bond, right? We are having a double bond, right? Isn't it? We have got a double bond. Suppose Cl, HH, we have got a double bond, isn't it? Or we have got what? We have got a we will be having we will be having a cycloalkane, isn't it? We have got a cycloalkane. So those also give you. Now, if you see when we talk about cis, see this is cis. Understood? This is cis. Understood? This is cis. And we are seeing what? This is trans. Can you see this? Trans. Can you see this? Get my point over here. This is cis we are getting. Cis and we're getting trans. Now, just unshare the screen quickly. Just 1 minute. Unshare the screen. I'm going straight to the book. Over here, see if we talk about the cis trans isomerism. Just give me 1 minute. I'm just trying to note down this part. Uh, if I come across a good question, I'll be sending you in that group to you. Huh? Just go over that question once, so that'll be really great. See, when you talk about the cis trans isomerism, how does it happen? How does it look? It see it will something like this will be there, right? See, if you see when we talk about system isomerism is due to the spatial, right. If you see isomerism, what is isomerism? Isomerism are the compound with the same molecular formula but different arrangement of atoms. Is it clear what is isomerism? Isomerism is the process by which the compound of the same molecular formula but they're having different arrangement of atoms. This thing we have to know, right? Same molecular formula but different arrangement of atoms, right? Now, if you see that when we talk about isomerism, there are two kinds of isomerism: structural isomerism and stereoisomerism. What is structural isomerism? Structural isomerism is the isomers where we have got different bonding. The bonding is different, right? Suppose we are taking this, right? Chlorine over here. See? And the next thing is this, right? We are taking chlorine over here. Can you see that what we are doing over here? Can you guide me, Biva? What we are doing over here? Here the chlorine is in carbon number 1. See? Here the chlorine is in carbon number 2. Can you see this? The bonding changed. And what are isomers? Isomers have the same molecular formula. This thing you have to note down. Same molecular formula, but different arrangement of atoms. Is it clear? They'll be having different arrangement of atoms. So this thing we have to master over here. They'll be having the same molecular formula, but different arrangement of atoms. Understood what is structural isomer? Now, what is stereoisomers? Stereoisomers are those which contain the same molecular formula, but different arrangement of atoms. But the arrangement of atoms are spatially different, isn't it? They are different spatially. Get my point? So they will be spatially different. So see, we are seeing chlorine over here. Can you see the difference? Can you tell me, Gaia, that where is the difference between this compound and this compound? The same bonding is there. See, in stereoisomer, the bonding will be same. Chlorine is attached to carbon number 2, and this chlorine is attached to carbon number 1. Here also chlorine is carbon number attached 1. Here chlorine is attached to carbon number 2. The same bonding. But where is the difference? Can you tell me, Biva, in these two compounds? Biva, can you quickly tell me where is the difference between these two compounds?
There
This
are
compound and
different
this compound.
themes.
They are on different. Yeah, they are in different three-dimensional, right? Position, spatial. This is the same side. Biva, Gaia, is it clear? This is the opposite side. So this is cis and this is trans. So in the cis trans isomerism, we have to look around for what? Where does cis trans isomerism come? The cis trans isomerism will be there for alkene, if you've got an alkene, or we have got a cycloalkane. Is it done this part? Understood? So this is cis, see, this is cis, and this is trans, right? So similarly, if you take a cyclobutane, see, this will be cis, and opposite will be trans, isn't it? Clear to you? So see, I'm giving the example. See, cis trans isomerism. So we have to make sure that we are putting the double bond in the center, right? We have to put the double bond in the center, isn't it? And what we are getting, tell me. See, this is cis. Can you see this? Cis. Understood. Understood. And this is trans. Understood this part. Always you have to arrange that double bond in the center, right? Your double bond won't be given like this. You have to arrange that. You have to draw the open structure, and after that you arrange the compounds in such a way. See, this is what cyclopropane. It will be coming in alkenes or cyclopropane. See, these are the same side of the plane, isn't it? Clear? And see over here, these are the opposite side of the plane. Is it clear? To get my point? See, cyclobutane, see, same side of the plane. And they're the opposite side of the plane. So this is cis trans isomerism. Now I hope that you will be having a better grip now, right? Yeah, Gaia, tell me. Thank you so much, Gaia. Tell me.
So, sir, it never happens with
Either it will
like
be a cycloalkene or an
benzene.
alkene. Tell me.
So it never happens with benzene.
Benzene can be, right. Benzene has got a also, yeah, no, benzene see, benzene will be having, suppose we are taking hydrogen. Good question. Suppose we're having chlorine over here, right? We're having chlorine over here. And we're having chlorine over here, right? Benzene, it can happen also. Benzene is a flat molecule, right? Isn't it? Benzene, this is sp2, sp2. Benzene, uh, no, benzene, good question. Benzene not won't, right? Benzene will be always having, will be having, benzene, chlorine. Suppose I'm taking this chlorine, right? It will be having the same side always, right? It cannot be this side, right? It can't be opposite side. Good question. Benzene, it cannot be, right? It's good question. See, Biva, we learn from others, right? In a joint session. See, good question she has asked. Very good. Biva, are you having any questions now over here?
No, sir.
Thank you. Can you share the screen quickly? Gaya, share the screen. Thank you. Is
Mhm.
it me too? Can you draw all the options over here? Can you draw all the options over here? See, this option cannot be. We draw all the options over here in systems, right? We draw all the options over here like this. We draw this option over here like this. This also can be systems. You have to have different groups over here, right? Over here, not the same group. See, the same group is there. So this can also can be systems. This Gaia, can this be systems? It cannot be because same group is there on the carbon, isn't it? It cannot be. Now come to this. Come to this particular part. See over here, how many bonds are there over here? Please tell me. In this carbon, if you, do we have a hydrogen? We need another hand also. Is it clear? Get my point? Understood. If this was the question, then this would have been done systems. Gaia, understood this part question? If this was
Yes,
the question, this would have gone for systems. Is it clear? Get my point? Are you okay? Are you understanding this part? Gaia, Biva,
yes,
understood this
sir.
part? If this was this, if you're having the carbon like this, right? If you're having this, then there would have been fluorine and hydrogen. Clear? Understood? And you could have flipped the places like this. Fluorine and fluorine over here. Then this would have been cystine. See, same side on opposite side. The question which you asked me, can you recall? You asked me a brilliant question just now. That will benzene have a cis trans? Can it happen? Can it happen? Cis trans? You need to have another bond. Is it clear? Does it have another bond? It does not, right? Get my point? That's the reason it cannot be cis trans. Understood? You need hands like this, two hands of carbon. Is it clear? Very good question you have got. I'm really appreciating the question you have got over here. Very good question you're having. So wonderful question you showed to me. But now you're okay. What do you feel? Huh?
Yes, sir.
Now you're clear. Just give me 1 minute, huh? Just give me 1 minute. Quickly, just 1 minute, huh? Just 1 minute. Just 1 minute. Give me 1 minute.